Video, I'm going to explain assembly language program in 8051 to move a block of n data bytes from source location 2000H to destination location 2050 using external RAM. So here both source location as well as destination locations are external memory. Okay, so it is 16-bit address and it is also 16-bit address. So we require 16-bit registers for transferring, but unfortunately 8051 has only one 16-bit registers which is used for programming. Actually two are there, DPTR and program counter. So don't touch the program counter, you have to use only DPTR. So let me open the code. So I'm going to show the code. So write an ALP to move the block of data. I am taking the block of data as 5 bytes. From source location is 2000H to destination 2050 using external RAM memory locations. So the starting line is actually org 000H. So it's the optional line. So it's the beginning of program. So move DPTR with uh, the source location address. Okay. Load DPTR with source location address. Okay. So I'm loading DPTR with source location address, which is DPTR is 16-bit register. So 2000H is also 16-bit registers. So now we are destination also 2050, which is 16-bit registers, but only one register is available, the DPTR 16-bit register that is used for source location. So now we have to use two 8-bit register to hold the address of destination. So I'm using R0 and R1. So R0 is loaded with R0 is loaded with your destination. Okay, destination destination location lower byte actually. It is a 16-bit, no, lower byte 2050. So lower byte I'm loading in R0 and R1 is loaded with, okay, R1 is loaded with upper byte. R1 is loaded with upper byte. So why I am using two 8-bit registers are means only one 16-bit register is there in 8051. So that is used for that is DPTR and it is already having 2000H. So no other 16-bit registers are there for programming. So program counter is there that don't use here. So you have to use two 8-bit registers to hold the destination location 2050. R0 is having 50 lower byte, R1 is having upper byte. So after that R2 is actually loaded with block size. R2 is loaded with block size. Okay, 5 is the block size. So if you are transferring a block of 10 data, then you have to load 10 here. Next, first we have to get the source location content into the accumulator. So always whenever you have data transfer related to external memory, along with the move, you have to use X, additional X you have to use. So this actually indicates that accumulator is equal to accumulator is loaded with accumulator is loaded with content of content of address which is present in DPTR. DPTR is 16-bit register. In that 16-bit register, that 16-bit address will be there. That content will be moved to A. After loading to the A, okay. So in order to transfer to the destination location, which is stored in the R1 and R0, so we have to take that values into the DPTR. So if you take that value to the DPTR, the original DPTR value will be erased. So this 2000 will be erased and it is loaded with 2050. So we want to store this 2000 original location. So you have to save it. So you have to push, okay, save DPTR value. So DPTR is actually divided into two register DPH and DPL. So DPTR into the stock. Okay, or by pushing save DPTR content into stock to stock. So stock operations are push and pop. So it is DPTR is divided into two register DPH and DPL. Deep data point are higher, data point lower. So after that, both DPH this will be moved DPH and this will be moved to DPL. Sorry, DPH content will be moved to the stock pointer. Stock again one more time push DPL. Next, we are taking move R3 comma A. A content is transferred to R3. What is A? We previous A is now move AX. The accumulator is loaded with content of 2000 H. No, that we have to store to R3. Some temporary location we have to load. I think this is also not required. Okay, let me check now. This register is also not required because accumulator content is not varying anywhere. Okay, we moved. Okay, we saved the content of DPTR into the stack memory by pushing DPH and DPL. After that, okay, we stored R0 and R1 with destination location. No, so again we have to load DPH with destination location DPH value. Okay, R1 content. R1 is nothing but destination. Okay, destination per byte. DPH is destination location per byte. Okay, again load DPL with, okay, again load DPL with R not content, which is actually having the destination location lower byte. Next, we have taken the 2000 content into accumulator. Still, it is in accumulator only. From accumulator, you have to move it to the destination location address. So now this content will do move accumulator content to destination location, which is 1050. Okay. So after that, you have to increment, increment DPTR. That is now DPTR is actually having destination location. Okay. So 2050 becomes 2051. Increment means increment by 1. Okay. Plus 1. So after that, once again you have to store. Okay. Again store that destination into once again back into the R1 register. Okay. DPH you have to store it in DPH content you store it in R1 register, and similarly DP1 content you store it in R0. So after that, your job is over. Destination is incremented while and that value will be loaded into R1 and R0. So now again you have to go back to the source location, which is 2050. We already pushed the content to into stack by using two push operations. Now you have to do popping. So you have to retrieve the content from the stack memory. So we have to use pop operation. So first we push out DPH, next we push out DPL. So popping you have to do DPL into DPL only. So that's why you have to do first pop, first DPL, then next pop DPH. So from stack memory, okay, you have to retrieve or restore. Okay, restore or retrieve DPL content from the source location. Actually, source location DPH and DPL. Okay, so you have to DPL both. You have to retrieve DPH as well as DPL. We already stored the two values DPH and DPL by doing two push operations. Okay, first we push out DPH, next we push out DPL. So DPL is actually pointed by stack pointer. So you have to first pop that DPL. Next you have to do pop DPH. So after that, now DPH and DPL contains source location. Now we have to increment source location. Increment source location also. Increment DPTR means increment source location 2000 is incremented by 1. Now it becomes 2001. So again now decrement, okay, decrement R2 which is counter if not 0, okay, then jump to label, to the label back. Back is the label name. So there is a back label at line number 7. It will go back here. So now I'll show the program. Copy this. Okay, now let me go to this remove old program. First, you have to stop the previous program if it is running. Then I'll click. Now I will remove old file. Now type add new item to the source. It is assembly program. So the program number I'll give external memory to external mem x to xmem. Add new item to the source group x to xmem1. So now I'll paste here. Okay. So the program is write a program to move a block of end data from source location to the destination using external memory. So origin is 000h. DPTR is loaded with source location address, and R0 and R1 is loaded with destination address. We are using two 8-bit registers because only one 16-bit register is available in 8051 for programming. So move R2 with 5 data size. Move X whenever we are transferring data from external memory or we are using external memory, you have to use X stands for external. So move X A comma dash DPTR, content of 2000 H will be transferred to the accumulator. After that, you have to save this source location by doing two push operations. Now get the destination address by transferring move DPH R1, move DPL R0. After that, from accumulator transfer to the destination address 2050. So increment DPTR, it will increment destination location. Again, you have to retrieve DPH and DPL of source location. Okay. First store this destination source destination address in R0 once again. Next, retrieve the content of source location. Source location also increment, then decrement. So let us compile this program. Build target. Start debug. So you have to use two windows, memory window 1 and memory window 2. So you can open memory windows here, memory window 1. So in memory window 1, both are external. So I'm using X, capital X, colon 0x 2000, enter. So here I'm giving 5 datas. Right click and click modify memory. So you can give 11H. You have to give H also, otherwise it will consider as a decimal and equivalent hexadecimal will be stored there. I'm giving 11h, comma 22h, comma 33h, comma 44h, comma 5h. So 5 data will be modified from the location 2000h. See 11, 22, 33, 44, 55. 5 data. This should be transferred to the destination. I'm opening one more memory window. Second memory window is there. In the second memory window, uh, destination location x capital X colon 0x 2050. See before transfer 2000 content is 1122334455. Destination is 2050 00000. So now these data should transfer to this location. So let us execute step by step. So go to the register and verify here also. DPTR is loaded with 2000. Okay. Next R0 is loaded with 50. R1 is loaded with 20. R1 is loaded with 20. R2 is loaded with 5. Observe here content. Okay. Move X. So whenever external memory content transfer is there, X you have to use. If you miss X, it will give error at the build time. So move X. The content of 2011 will going to accumulator. So accumulator 0 is there. Now it contains 11 here. Now you have to push this data DPH and DPL. So actually the stack pointer value is, you can see stack pointer is pointing to 0x07. So you can open memory window 3 and here you can give 07 as whenever you push that content will be coming here. So now I am pushing DPH and DPL. See 00 came here, 20 came here. So 220 lower byte and this is upper byte. So I am checking in the memory window 3. So after that, okay. So we have to get the R1 content to DPH. R1 content DPH is now 20. Now DPL will become 50 now. 00 becomes 50 now. So now DPTR is actually pointing to the destination address 2050 2050H. So now it will be copied to this location. So move X to the address specified by DPTR from A. Accumulator content will be copied to this address. So it came here. So first data is transferred. Again, this also destination is incremented to 2051. Now you can see here it is incremented by 1. Now again store the DPH and DPL into once again in R0 and R1. Okay, it is incremented to R0 and R1 here. Again you have to pop from the stack pointer. Okay, this will be popped to DPH and DPL. See it is popped this value. Again increment DPTR. Now DPTR is actually pointing source location 2000. Now it is also incremented by 1. Now decrement R2. If it is not equal to 0, go to the label back. So it went here. So see first data is transferred here. Similarly, it will repeat. Now second data is transferred. Similarly, third data will be transferred. Fourth data is transferred. Fifth data is transferred. After 5, R2 becomes 0. We are transferring a block of 5 data. So when R2 becomes 0, it will not go to the label back. Okay, it will end the program. So it will end here. So the answer how to verify. Before transfer, we entered 5 data into location by right clicking here and modify the data at 2000 location. We entered 11H, 22H, 33H, 44H, 55H. In the second memory window, we opened and we entered 0x2050. Okay, 0x colon x colon 0x2050. Initially all are zeros. So if you execute step by step, So we have to click step over. So at the end of the program, you are going to see the data are transferred to the destination memory. Here both source as well as destination both are 16-bit, so it is external memory. And if you want to see the stack memory also, you can check it out in the one more memory window where you can see the stack pointer. It is pointing to 0x07. In this 0x07 you can see the content. Okay, what are the values you push? No, that will be, you can observe here also. That is optional. You concentrate only on source location and destination location. Okay, thank you.